शुरू करने जा रहे हैं। नया टॉपिक है हमारा पुश डाउन ऑटोमेटा। नया टॉपिक है पुश डाउन ऑटोमेटा। Push down automata. The basic definition of push down automata is a push down automata. A push down automata is a way to implement context-free language. Context-free language. In a similar way, as we have done in designing finite automata for regular language. As we already discussed about the Chomsky hierarchy, and now we are discuss here Chomsky hierarchy. Chomsky hierarchy, that there is four type automata, and these four type automata is in the form of like this. Suppose this is the first automata, finite automata, and then this finite automata can understand on the regular language, then if there be some another automata, mean bigger one, that is the some restricted part, that is a push automata, push down automata. Then there is a language which can understand push automata, that is context-free language. Context-free language. And similarly, we can understand the health of grammar. There is a language, then there is also a grammar, regular grammar. They can understand only the regular language. And again, there is a context-free grammar, which can understand the context-free language. Then there is another automata. That automata is LBA, linear bounded automata. That can understand by the language, understand the language. The language is case sensitive language. Already know about the case sensitive language. And there is a grammar which can understand the case sensitive language. There is recursive grammar. And there is another automata, fourth automata, that is Turing machine. And there is another language, that language recursive, recursive, enumerable language, and that can be understood by the grammar. That grammar is recursive grammar or unrestricted grammar. Unrestricted grammar. There is a four kind of automata. There is four kind of language, and there is four kind of grammar. Each setup automata can understand by each set of language, and each set of language can explain by each set of grammar. Then this is defined by the Chomsky hierarchy for the time how can understand the automata in the form of language and in the form of grammar. And now second thing is uh, what is the structure, yeah, what the block diagram of the automata. Then if we study here what is the PD. Well, the block diagram of the PD is like this. Suppose the finite automata, you are already understand the finite automata. There is an input tape symbol, there is input tape symbol, and there is a final control. There is a final control. That is a read write head. This is a read oblique write read. That is a read head. That is a read head, which can read the input alphabets from the input tape. They finite control, and we are using the additional element stack of the finite automata, which can process the language of the contextual language. Then this stack is an important role. There is a memory element. This stack is a as a memory element which can store the data inside the stack. And in the finite automata and Pushdown automata, there is only the difference of this stack. You can use only the additional component stack as a finite automata, then they can define as a PDA. Then this is a block diagram of the PDA, and the component of the PDA is an input tapes, that is the same as in the finite automata, finite control, that is also same as in the finite automata, and the stack with the input 0. And in that stack there is always using z0 as the top symbol of the initial at the beginning of the stack when the processing will start. That top symbol of this that is called the top symbol of the stack. Then this is a block diagram. That block diagram is same as the finite automata, but the difference is we have used the additional element stack as a memory element to store the input data of the language. And now what is the PDA? And now what is the PDA? Now this is the PDA. And now what is the PDA? Pushdown automata, the definition of pushdown automata, that is the when we already seen in the finite automata, there is a collection collection of 5 tuples. But in the pushdown automata, there is a collection of 7 tuples. There is a collection of 7 tuples. As you have seen here, machine pushdown of P is equal to Q0 sigma uh, and gamma delta Z0 capital Q and QF. Where we already have seen the 5 tuples before in the finite automata. Then that 5 symbol is Q0 sigma delta capital Q and capital F. These are the symbols which already have discussed in the finite automata. and there is only the two symbol. One is your uh, gamma and one is your z0. There is two new symbols are encountered in the PDF due to the stack as a memory element add in the diagram. Similarly, Q0 it is a special state called the initial state, and sigma is it is a finite non-empty set of input symbol. There is no problem. It is already in the, and now this symbol is gamma. It is a finite non-empty set of pushdown stack symbol, and the symbol which you have pushed into the stack, that is called the pushdown stack. The symbol, yeah, that and the values which are in pushed into the stack, that is a pushdown stack symbol, which are stored in the stack. Then there will be z0. Z0 is only the special symbol which is called the initial symbol of the stack inside the stack, that is z0, the top of the stack. And the capital Q, it is a finite non-empty set of state and denoted by capital Q, and QF it is a set of final state already know you. And delta, there is a big uh, question mark in this delta. And the delta it is a transition function, as you already have read in the finite automata. Q cross sigma of epsilon, sigma union epsilon cross delta, cross gamma. It is set of finite state that may be defined as a Q cross sigma. Until unless you have the value into the stack, they can check into this value. You will just check and see here. You will just read the input from input tab A, read, check the finite control state capital Q, that is the sigma over capital Q, and then check the top symbol of the stack. What is the top symbol at that time? Then if you check the input symbol at present time, what is the state, current state, and what is the current top of the stack? When you combine these, then you can get the output. What action should be required? What state you are getting? Then this is called your Q oblique sigma, and that will get the desired result in the form of this. And that the Q is the current state, what is the input, and what is the top symbol of the stack. And this is the methods how to process the PDA. And now there will be some operation, the operation of the push down automata. And the operation is there is basically three operation in the PDA, and the operations are push operation. First operation, push operation. What is the push operation? How the data will push inside the stack. Suppose there will be empty stack Z, and suppose the input alphabet is A. Then how you put this A inside the stack A, inside the stack value A, and if the input is B, then how the store that B into the inside the stack. Then suppose there will be a state Q0 state, and there will be some new state, that is a Q1 state. Suppose input alphabets is A, and the current symbol of Z, that is a starting symbol of the uh, stack, that is Z0. Then if age input, if you want to insert the value, yes, if you want to push the value inside the stack, then A is the input alphabets, Z is the top symbol, then the operation will A Z0, that will be the A Z0, and we can move to the next state. That maybe this we can do the same state, but here we are going to next state. Then how you can write it this can you write in this form, delta Q0, A is the input alphabets, and Z is the Q is the input alphabets, Q is the state, A is the input alphabets, and Z is 0 is the top symbol. Then if you apply the operation, then what you want, if we want to put store the A inside the stack, is push operation, then the value is Q1. We are going to reach on the Q1 state, and the operation is A Z0. This is the how we get the operation. Now similarly, if we are in Q1 state, that B is input, and that time the top is A, the stack top is A. When B is input, then top is A. Then in this time, if you want to push that B inside stack, then B should also push. Then there will be A in this form. Then what is the methods? How do we write the syntax? Then the delta, and right from delta, Q1 input symbol B, and the top of the stack is A. Then if we want to push operation, then we can go to the Q2 state, in which state you are going. You are just mentioned here Q2 state, and what operation you are doing, you are doing push operation. It means B, then A is already there, and B is the current symbol which are inserted into inside the stack. That will be like this. Then you are getting the final state, means final inputs, which are going to insert into the stack. Same, if you want to do the pop operation, second pop operation, then in the pop operation, if there will be a stack in the same as B A Z0, there is same operation B A Z0, same elements. Then if we want to pop up the B from the stack, then suppose you are in Q0 state. Suppose you are in Q0 state. If input is A and the top symbol is B at that time, because B is the top of the stack, then if you want to pop up the B from the stack, then we have to follow the operation epsilon in the place of top symbol. Then if again we want to exit, if you want to get the second symbol, pop up the second symbol from the continuation, then if there will be A and there will be top symbol A, then again they can be pop up. This is the operation. Then again we can pop up the A, then last is Z0. Then how you write it? If we are starting from Q0, then if you are in from Q0, then A is input. Then if the top symbol is B, top symbol means top of the stack is B, then if you reach the Q1 state, and if you want to pop up that top symbol, then remove the top symbol B from the stack. Then we cannot get the what is the next top of the stack. We don't know nothing about this. Then we put the value epsilon in that place. Similarly, in Q1 state, if you want to again remove the if you want to again pop up from the A from the stack, then you can follow the same operation again. Sigma Q1 input is A, then the top symbol is A, then pop that A from the stack, then we can get the Q2A. It means the both symbols will be popped up. Then finally we are getting the Z0 as the top symbol of the stack. And the third one is your skip operation. If you are don't want any action, now you cannot insert the value inside the stack, or you cannot remove the value inside the stack, then how to escape the operation? This operation no push or no pop operation. Only the input string will be consumed. You can just read the input string from the alphabets, means you can move the alphabets forward, but you cannot take any action in the stack. It means if you are from Q0, if A is there as the input alphabets, and if A is the top of the stack, then if you want to not any action, then you can go any state, means Q1, but the top of the symbol will remain same. You have not any action on the top of the stack. Then this is the method how to take the operation on the stack. Now let us take the example, one example of the for the PDA. Another example. Suppose the language L is equal to A की power n, B की power n, such that n greater than 0 is accepted by PDA. And now suppose solution. and now the L is in the form of like this: AB, AA, BB, triple A, triple B, 4 times A, 4 times B, up to so on. And now let us explain the with the help of block diagram. Suppose there is a block diagram, the input tape. Now you want to put any string from this to check for the language processing. Suppose we are using this string A, 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 B, 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 and there is finite control, read head, there is finite control, and there is a stack, there is stack, and there is a output operation which you have to perform. And now in a stack, initial there is Z0, and there will be epsilon with blank symbol, and there is also blank symbol from the input tape. That is a input tape. Input tape. This is input tape. There is a finite control. That is finite control is a form of sigma q, and there will be again a cross product of stack, that is gamma. There is a form of finite control. Then if you want to perform this language, and this language there is a exact number of A's and exact number of B, means the number of A is equal to number of B. Then if you want to process any language which has equal number of A equal number of B, but the condition is first A is encountered, then B is encountered. In this case, if you want to process this from the finite automata, then if you want to construct the PDA, then construction of PDA, that is PDA. Then if suppose you are starting from Q0 state, this is initial state of the PDA. Now the input is A, the top symbol of stack is Z0. Then suppose if you want to try that, you can just put the all of the A symbol A. If you want to push all the symbol A inside the stack until B is encountered, and when B is encountered, B is input, coming input, then A is pop up from the stack. We are just taking simple logic from this. Then if you put the first alphabets, suppose A is there, first symbol A is encountered, then suppose the top of symbol is Z0 at the beginning starting. Then if you want to push that A inside the stack, A, Z0, and then we can go to the new state, that is Q1 state. This is the first operation. This is the first operation. Suppose when you can just insert the first element in the stack, then if A is encountered, we can push the A inside the A. Then the first element will be stored inside the stack. It means there will be Z0, then A is there. Then if we want to push all the symbol from this, then we are using same loop, means same operation, repeat operation. Then if the A is input, and if the top symbol is A, because at this time the top is A, then if you want to push the A, then we are getting the operation like this. This is the operation, and you can get the same state. In the Q1 state, we are using all the push the all the A inside the stack. Same again, if we read the next A, then again there will be again a push symbol, push operation we also already have discussed. And now if again B is encountered, this B is encountered as input symbol, then if you want to pop that if you want to pop the number of A, because 3A is stored inside the stack, 3A is stored in push inside the stack, then B is encountered. Then if you want to pop the first A, if you encounter the first B, then we are using here if B is input, if A is the top of the stack, then pop up A, pop up the stack A. It means you can go to the state Q2. In this operation, we have do the pop operation. In this operation, we are using the push operation. And now, when the first operation will be performed, now we are using the stack, and you can just there is a push operation. Again, there is a pop operation Z0 A, then only the two A are there because they are popped. First A is popped because first B is encountered. Then similarly we can pop up all the A's with the help of B's. B is there, A is at the top of the stack, then pop up the A. Then finally, if the number of B means there is only 3B, this last B. If there will be nothing on the tape symbol, it means if you are getting only the epsilon in the top in the input alphabets, and if there will be a Z0 on the top of the stack, then keep it as it keep as Z0 as Z0, and keep Z as a Z0, and go to the final state. That is the final state of the automata, because the Z is the top symbol and there is nothing inside the stack, and we have traced all the input symbol. It means this this operation, this operation, this is the PDA. This is a PDA. You can say this is a block diagram of PDA. This is a push down automata, and then we can write here in the form of delta. We can write this in the form of delta. If we write in the form of delta, function delta, then we can write here this Q0 A Z0, that is Q1 A Z0, and again Q1 A, there is again Q1 AA, Q1 AA, and then is again Q1 B A, there is again Q2 epsilon, and there is Q1 B, sorry, Q2 B, the alphabet, say the top symbol, then Q2 B, Q2 epsilon, and finally if Q2 epsilon Z0, then QF Z0. Now this is the total function, transfer function delta, which can represent the PDA in the form of symbols. Language. This is a language. That language is contextual language because we already have test through the pumping lemma in the CFG. Then we are using the block diagram. This is a block diagram, how to understand how to perform the push operation. Then we have construct here PDA. with help of SAM, as you have already do in the finite automata, there is the number of states, number of input alphabets, number of final states, intermediate states. Then we are uh, using the transition function delta. That is transition function delta q0 a is the input, that is the top symbol. Then we are go to the q1 state. Then q1 state q1 a z0. Then same is here. You are seeing here. If you are in q0 state, is a is input symbol, z is the top symbol, then you are using push a and you are getting the q1 state. Same we have here find the operation here, q0a z0 q1 and a z0. Same in q1 a state, q1 a is the input, a is the top symbol, then we will represent the same state a and perform the operation, input operation. Then if we are in q1 state, if we are in the input symbol a, if the top symbol is a, then operation is performed push symbol, we can get the same state q1 state. Then similarly we are using q1b at top of the stack, then reduce means pop that a from the stack, then that will be epsilon. Then in q2 state, b is there, if top is a, then remove all the stack symbols. Then finally, if you getting the input alphabets in q2 and just the top symbol, then you are getting the keyword state, that is that symbol. That is the overall result of the problems. Thank you.